discuss one of the electronic gadget which used in the development of the electronic circuit, that is a vacuum tube. So, today we will discuss about what is the vacuum tube, types of vacuum tube, what are the application of the vacuum tube, what are the advantages of the vacuum tube, we will discuss in the further this lecture. Now, what is a vacuum tube? Vacuum tube is a device that was developed by the physicist in 1904. It was developed by the Fleming, and it contains the electrodes to control the electron flows, because we use the electrodes here that will use for the flow of the electrons. Generally in the sealed container it is put, and it is used to control the flow with the help of the vacuum. Now, in early computers it was used as a switch, as an amplifier, and it is known as a valve, and it is also known as an electron tube. Nowadays sometimes we will call it as a electron tube, and you can see on the screen that this is the vacuum tube that was used in early 1900, and sound, it was used in the television, sound recording, industrial automation, reproduction, radar equipment, radios and telephones network system, and it is a predecessor of the modern transistor, that means as the transistor may be used today. So, the vacuum tube was used in creative ways as a electronically controlled rectifier, oscillator, switches and the amplifier. You see on the right hand side, you must have seen this type of the vacuum tube in many electronic devices. Now, in the older computer monitors and the televisions, the CRT, cathode ray tube, was widely used, and as a screen and the kind of the, as it is a kind of the vacuum tube. First, it was invented as a basic component for the electronic device and most commonly used in the evaluation of analog as well as the digital computers in the first half of the 20th century. The vacuum tube produces electrons and an anode, as it was made of the cathode, and the anode collects the electrons, that called a diode. However, there were other kinds of the vacuum tube available which were categorized on the basis of the number of the electrode presented. So, vacuum tube produces the electron, where what we have, an electron is made of the we have a anode and we have a cathode that will collect the electrons, and that is also known as a diode. So, these electrodes are surrounded typically in a glass, and in a casing we will put it, and it energized enough, and it can act as a conductor with all air detached. So, as lightning travels through the air, in the same way a pathway becomes for the electron. So, movement of the electron will produce a pathway through the air in the vacuum tube. So, a pathway become for the electron, therefore, it is commonly known as a vacuum tube due to the shape of the vacuum. So, vacuum tube produces a lot of heat and it needed massive amount of the power, because it requires a heating filament for producing the electrons. So, due to a lot of heat, components were quickly degraded, therefore, they burn out quickly. In order to work, 3 different power sources are also required by the vacuum tubes, which are based on the capacities and the rating. So, power consumption and the size became smaller with the progress of the vacuum tube technology. So, nowadays vacuum tube technology is a most of burning topics that were used in the material science. So, they were cost effective, moreover the transistors work efficiently only for the low frequencies. With the transistors in the cascade, 100 transistors in the parallel and the wire together will be required for the high frequencies. That led to the need of the heat sinks which create the massive heat. An equivalent transmitter needs significantly less power, only uses the single tube. So, it can be coded with the help of the force here or the water cooling. The speaker damped effect of the vacuum tube solid state amplifiers cannot repeat the peculiar distortion. So, sound amplifier, the vacuum tube are more common. Similarly, the vacuum tube started to replace the transistor in 1950s. Due to the size of the transistor, they were become the much ideal to use as a size computing devices started become the smaller. Nowadays, we use the ICs in place of the vacuum tube. In the smaller computing devices, vacuum tube did not fit as they were large in the size. So, they let becoming the using the less useful. So, additionally today vacuum tubes are still used, and where we used it, the vacuum tube are still used in the high end audio equipments. Moreover, they are used in the big radio stations, especially those when we are using the frequency more than that of the 50 megahertz and energy levels more than that of the 10,000 watt. So, the vacuum tube technology is not completely obsolete. Nowadays, we also use. Then, what is the vacuum tube technology? Vacuum tube or the thermionic valve technology is based around the basic concept of the thermionic emission. So, the concept of thermionic valve or the vacuum tube use the idea that a heater element in the vacuum emitted electrons that would normally remain in the vicinity of the heated element and because of the charge attraction. And in this manner, the second electrodes are placed into the vacuum and a high positive potential placed on it. Then the electrons would be attracted away from the heated element towards this element which is having the high potential. As a result, a current would flow in this direction. So, it will move from high, it will move to the high positive direction. So, and electrons were unable to travel in the reverse direction. This simple valve or the vacuum tube acts as a diode. It is moving in the one way. So, it is also possible to place a third element which is known as the grid. You have seen in the further slide you will see that there is a third element which is a grid into the structure between the two electrodes. We use the grid, and this electrode is normally formed of a gauze to allow electrons to pass through. So, by varying the potential on the one of the electrode, the flow of electrons can be controlled. So, in this manner you see on the screen that this is the anode and the bottom we are having cathode, and there is a grid in between that which can control the flow of electron and the movement of electron from anode to cathode, and there is a heater, and you can see the circuit symbol for the this is circuit symbol, and for the vacuum tube or it is showing the how the electrodes are working. So, they are the number of the electrons in the valve or the vacuum tube. So, what are the number of electrodes? First we take it as a cathode, second is the anode, and third is the grid. What is the cathode? This is the electrode that is heated and emit the electrons. So, from cathode to the anode we pass the electron, the cathode generate the electrons. So, this is the electrode that is heated and emits the electrons. Now, anode, this electrode in a vacuum tube or the valve has a high potential to attract the electrons from the cathode. You can see here that from the heater we will use just to eject the electrons from the cathode, and from the cathode it will move towards the anode. So, cathode will eject the electron and anode has a power to absorb or to attract the electrons. So, it is one type of the valve. Now, what is a grid? Grid, this is a valve electrode that has a variable potential and is used to control the flow of electrons between the cathode and anode. Now, as the electrons are moving from cathode to anode, this grid will control the flow of electrons. So, in some vacuum tubes, more grids are used to improve the performance in the various way. Like we use a filament, that is the most of the walls these days are indirectly heated. So, a filament is not connected to the cathode. So, filament heats the cathode, which then emit the electrons. So, the filament heats the cathode. We use the filament for the ejection of the electrons from the cathode. So, the filament heats the cathode, which then emits the electrons. Early walls were directly heated the filament and was used to emit the electrons. However, this placed limitations on the way in which the valve could be used. So, having an indirectly heated cathode allows the cathode to operate at a potential higher than the ground, and also for many filaments to be run in the parallel in a single item of the equipment. So, we will use a filament just to heat the cathode. So, filament is also the important part in the tube. So, we will use the filament in the just to heat the electrode. Next, we will discuss the different types of the vacuum tube. Vacuum tube is an interesting cleaning element that is used in the various ways for the several purposes. So, the vacuum setting, these tubes mainly contain the cathode, anode and the grid that will control the flow of electron. So, there are the various type of the vacuum tubes which we discuss here. The first vacuum tube is the diode vacuum tube. The diode is, this is the simplest form of the vacuum tube that contains the two terminals. One is anode and second is the cathode. When the cathode is sufficiently heated, then it ejects the electrons, and these electrons transfer from the surface due to the thermionic effect. Because of thermionic effects, as we are heating the element, then the electrons are ejected, that is a thermionic effect. Through the thermionic effect, the electrons are transferred from the surface of the material. And if the cathode contains a high electric potential and we apply it to the and is applied to the anode, the cathode emits the negatively charged electron that are attracted to the anode. So, it is the simplest type of the vacuum tube which is containing the cathode and anode. Cathode eject the electron and anode will attract the electron. So, electrons that are attracted to the anode. The electric current via the convection go in the direction of the positive charges. So, therefore, the flow of electrons is always considered from the cathode to the anode. The main reason behind it that the current of the negative charges going in the same route is equivalent to the current in the positive charges in the opposite direction. So, we can see here these are the sum of the pictures of the vacuum tube. As compared to the cathode terminal, when the anode has higher electric potential, the released electrons get attracted towards the anode. You see here, if we see clearly, then we can see we are having a electrode here. One is anode and one is cathode. And second type of the vacuum tube is the triode. What is the triode? How can the current flow from the high potential V plus? It is another type of the vacuum tube where the electric current flow from the high potential V plus. However, a valve is still needed that allows controlling this flow. So, in the triode, we use the third terminal, and the third terminal is the grid that will control the flow of current. A grid is needed that is placed between the cathode and the anode. As compared to the cathode, when the electric potential of the grid is lower, the cathode emits electrons that are repelled and help to find difficulties to reach the anode. At this control the flow of the electron. If we say that when the electric potential of the grid is lower, cathode emit the electrons that are repelled and help to find difficulties to reach the anode. So, the movement of the electrons between the terminals controlled by this grid. If the grid is negative enough, its currents gets blocked. So, obtaining the same effect that helps to close the valves in the hydraulic circuit, then we can get the we can have image of this like now third type is the tetraloid vacuum tube, and this is a primary intention of the creation of the triode was related to the introduction of the tetraloid vacuum tubes. Now between the anode and the grid, the tetraloid contains a fourth electrode that is called a screen. The main objective of this advanced component is to short the capacitance produced by the anode and the grid. So, this tetraloid we are having a fourth electrode, that is a screen that will short the capacitance which is produced in the anode and the grid. So, the grid and the anode both work like a small sized capacitor in the triode, as they are located very close to each other, which may lead to instability and oscillations. Now, while we comparing with the cathode, if the screen consists of higher voltage but has a lower voltage as compared to the anode, it reduces the inherent capacitance of the grid, and the anode through the working of the electrostatic screen between the grid and anode. So, you have the picture on the screen, and this is the one type of the electrode. At the anode side, in this type, this help giving the fractions of the output signals, and the screen is also said to work in the ultra linear structure. Moreover, with respect to the cathode, the screen is positive to the tetraloid, and therefore, the electrons emitted from the cathode that are attracted by the screen in some amount go towards the anode. Consequently, through the screen there will be a smaller current flow in the circuit. So, this effect is used at the time of configuring vacuum tubes to work in the ultra linear modality, or when we are using the distributed load. And instead of applying a fixed voltage to the screen, this configuration is acquired with the help of the feeding back a percentage of the output signal to the anode to it. So, the required anode output signals percentage is offered to the screen with help of connecting it to the tap from the output transfer. So, current through the screen offers a kind of the negative reaction, and that valve distortion was minimal, and because of this the value of the distortion was minimum, and percentage of the anode signal is appropriate, which leads to the reduce the power efficiency. The appropriate percentage is determined by the specific electronic vacuum tube we are using. So, generally this percentage is set up to the 43% in the most of the available design of the power amplifier. The fourth type is the pentode. Pentode vacuum tube, that is the main idea of creation of the pentode was further refined for the tetrode vacuum tube. Now, in this type of vacuum tube, whenever the cathode emits the electrons and reaches the anode, there are more chances that they have enough energy to stimulate the emission of the secondary electrons from the anode itself. So, when the secondary emission electrons reaches the grid, they might be caused to instability and oscillations. So, there is the fifth electrode which is called the suppressor that is used by pentode to prevent the secondary emission electrons. So, in the previous one we use the screen and now we use the suppressor. So, generally the suppressor is directly connected to the cathode and helps an explicit connection between the corresponding pins and using a connection inside the vacuum tube, and this is used to prevent the generation of the secondary electrons in the anode. So, we can have this type of vacuum tube. This is the pentodes. So, this is the one type of the vacuum tube. What is the principle behind the vacuum tube? The vacuum tube or the electron tube contains the two or more electrodes, as we discussed earlier, that are separated through the ionized gas or the vacuum at a low pressure. Through the tube from the one electrode to the another, its operation is depending on the basic generation of the transfer of the electron from one electrode to the another electrode. So, cathode is a source of the electron, usually a metallic electrode emitted by the cathode. So, a magnetic field and electric field or both works for controlling the movement of the electrons emitted by the cathode. So, magnetic field may be produced through the permanent magnet or an electromagnet outside the tube. In a simple form, we can say the positive electrode, a plate or anode, appeals and accelerates the electrons, and the negative electrodes cathode repels and show it. What is the history behind the vacuum tube? Vacuum tube is a device that was first developed by the Fleming, and he just defined it the vacuum diode, thermionic wall, thermionic tube, canton that is used. Fleming was not only known its electronic contribution, but it played the vital role in the field of the wireless telegraphy, photometry and the electric measurements. So, he was then he just used this electrode for transfer of the current or transfer of the electrons from one circuit to the another circuit, and the alternate current transformer was also discovered by him in 1889. So, Fleming diodes were suppressed by the solid state electronic technology, and it was used in radars and radio receivers or many decades afterwards. Vacuum tubes allows much development in the first half of the 20th century. So, such as the first electronic digital computer, long distances telephone services, radio broadcasting and the television. Although the vacuum tube has almost been replaced by the transistors, and a used vacuum tube may still be seen in the certain devices like microwave ovens, display devices for computer and television sets, and the high frequency transmitter or the space satellites. So, as compared to the hot filament, the extra electrodes is made more positive. So, the direct current moves through the vacuum, and extra electrode is known as the plate or the anode. What are the advantages of the vacuum tube? One of the best advantages of the vacuum tube that it can be replaced easily. Vacuum tube have the ability to function at a high temperature without getting any defect. They provide the better sound quality. What are the disadvantages of the vacuum tube? The size is one of the biggest disadvantage of the vacuum tube, as they are huge in size. While comparing with the semiconductor devices like integrated circuit, transistor and diodes, the vacuum tube having the larger size, and now it is the things are going to be miniaturized. So its size are bigger, so it is one of the disadvantages. They produce much heat and needed high energy to operate them, and moreover they are more costly and consume more power. As compared with transistors, vacuum tube occupy the more spaces. The failure rate of the vacuum tube is high. Now you can see they are the sum of the summary sheet of the summary sheet of the vacuum. If you talk about the generic name of the vacuum tube, triode, tetrode, pentode, hexode, haptode and octode, and we are having number of the electrons and number of the grid electrons. So, this up to this we have discussed what is a vacuum tube, how we can use vacuum tube and how they work, moreover then how many types of the vacuum tubes are available. Thank you very much.